I'm Jeff. I'll be the talking head guiding you through today's presentation. I hope that all of you are holding up alright through coronavirus, and I hope that your family is staying safe as well. But with that, let's learn about biometrics. First, I'll be giving you a quick introduction to biometrics. Then, I'm going to walk you through some interesting use cases and the ethics surrounding them. After that, I'll let you guys free. Anyways, time for the crash course. First, we need to be on the same page when talking about biometrics. Bayes defines biometrics as biological characteristics that are unique to an individual. This includes things like fingerprints, your voice, your face, your hands, your eyes, your DNA, and more. I'm not particularly happy with this definition though, as it only encapsulates physiological traits under the umbrella of biometrics. So instead of using Bayes' definition, we're going to be using this definition, provided by Anil Jain and her awesome team of biometrics researchers. She defines it as physiological and behavioral characteristics that describe an individual. This newer definition includes all of the physiological traits that we just learned about, and various behavioral traits. So, add your handwriting and signature, your gait or your walking style, and your keyboard typing patterns to the list of things that are considered biometrics. Now, let's get into pattern recognition. There's a lot of interplay between pattern recognition and biometrics, so it's extremely important to get a good grasp on it. Bayes defines pattern recognition as recognizing similarities among different things. It's a very simple and abstract definition, but it encapsulates pattern recognition quite well. Pattern recognition is extremely useful because once a pattern is isolated, it can be analyzed and predictions can be made based off of it. In computing, we use pattern recognition to find patterns in data. Nowadays, artificial intelligence is used to efficiently find these patterns, but there are also non-AI based pattern recognition schemes. Pattern recognition has a wide range of applications, but we're going to be talking about how it's applied to biometrics. When we combine biometrics with pattern recognition, we get biometric recognition, the ability to automatically recognize individuals by various biological and behavioral characteristics. Some examples of biometric recognition include fingerprint recognition, facial recognition, handwriting recognition, and more. Anyways, let's get into the nitty-gritty. Let's learn about how these biometric readers actually work. The first key interaction that takes place is between the user and the biometric reader. So, someone might place their finger on a fingerprint reader, position their face in front of the camera, or write their signature on a drawable device. The sensor converts that input into raw data. It's important to note that when someone interacts with the sensor, there can be various sources of noise, or factors that affect the quality of the biometric reading. For example, maybe the sensor isn't that great, or maybe your biometric tree has changed some over time. Biometric data is then relayed to the feature extraction algorithm. These algorithms can vary quite a bit, but their main purpose is to find patterns in the biometric data that can be used to identify someone. Previously, someone would design these algorithms by hand, and they would isolate certain features from the input data. For example, someone might write an algorithm that isolates fingerprint ridges from a fingerprint reading. Now, thanks to the power of machine learning, we can use artificial intelligence to come up with feature extraction algorithms for us. Data representing the extracted features is then sent to a system that contains templates, which is just a fancy word for entries in a database with biometric data and identities that they belong to. One thing to note, however, is that there are some system implementations that don't explicitly tie a user to the biometric data. These are useful for things like access to buildings, where a set of templates of people who are authorized to enter is all that's needed. But assuming we're going with the first implementation, where the templates are tied to a user identity, two things can happen: enrollment or recognition. Enrollment is the process of creating a new template entry to the system. So for instance, when you first set up a fingerprint reader on your phone or your laptop, you're enrolling your fingerprints to the set of stored templates. Recognition is the process of trying to match the extracted features to a stored template. Whoever owns the end system is in charge of what happens in the case that a fingerprint is successfully recognized or if it's not recognized. Maybe the system returns the identity to the user. Maybe it opens a door. Now that you understand the basics of biometrics, let's get into some use cases and ethics. Generally speaking, biometric recognition is used in the same way that passwords are used. They provide, on the basic level, identity verification. So, any place where you can imagine a passcode being used, you can also imagine biometric recognition being used. The pros of biometric recognition revolve around them being distinctive, permanent, and convenient. They're distinctive in that most of the physiological biometrics, they're generally unique to a person. It's difficult to come by a legitimate duplicate of a biometric. Distinctiveness comes into play even more when you consider the possibility of multimodal biometric recognition, where multiple biometric traits are used to verify an identity. To some extent, biometric traits are permanent, or at least slowly changing, so you don't have to worry about the possibility of a trait changing so much that you're denied access to a system. And what's really nice about biometric recognition is how convenient it is. You don't have to remember a password or spend the time to enter a password. Instead, you just need to make a quick interaction with the sensor. The bad parts about biometric recognition revolve mostly around privacy and security. With privacy, in a world where readers are becoming more common, how does one preserve their anonymity? And how do you hold organizations accountable in their use of biometric data? And with security, biometric systems are vulnerable to attacks. Perhaps someone spoofs a biometric trait. There was an interesting story about how AI is able to spoof fingerprints in full biometric systems quite well. Or maybe there was a data leak for a database of templates. There was an instance in the UK just last year where biometric templates for over 1 million people were leaked. It's pretty scary stuff. Anyways, let's get into some of the more specific use cases. In the consumer realm, biometric recognition is used to log into phones and accounts, authorize payments, and is used in various other two-factor authentication scenarios. The pros aren't that hard to conceive. Using a fingerprint reader or facial recognition system is a hell of a lot easier and quicker than using a traditional password. The downside of this convenience is that a lot of consumers aren't aware of how to manage their data responsibly. They might end up allowing companies to harvest their biometric data, or may use biometric recognition on systems that aren't the most secure. For businesses, biometric data is extremely powerful. It's used for a wide range of applications, ranging from getting a better picture of their consumer base through data collection, clock-in, clock-out systems, and security systems for the workplace. The pros are pretty straightforward given the applications. It helps the business operate in a way that accommodates their customer base better. It gets rid of long-standing pitfalls of traditional clock-in systems. In other words, you can't get your buddy to clock you in if there's a system that relies on biometrics. And the general improvements to workplace security are a good thing. There are some murky areas, though. Businesses aren't exactly known to be greatly responsible and transparent with the data that they collect. Businesses can also sell off biometric data, which is a significant privacy concern, considering the nature of biometric data. There's also not much legislation in the United States requiring businesses to be transparent about the data that they collect. So businesses have the ability to collect biometric data without you knowing. Also, in regards to the implementation of biometric recognition in the workplace, workers may get creeped out or stressed by the fact that their boss is requiring biometric readings. This is something called function creep. When it comes to the government, biometric data is extremely useful. It's used in law enforcement for identity recognition and criminal behavior prediction. It's used in border control to identify migrants and look up their records. It's used in general national security to keep track of people, and it's used internally for identity verification systems in certain sensitive environments. The pros of the government using biometric tech is that it provides quick and easy record lookups, improving efficiency of government. It ideally promotes safety for the general public, and it promotes security inside of the government. There are some pretty major downsides, though. The government isn't always transparent about their data use. There needs to be measures in place to ensure that biometric tech isn't used to discriminate based off of certain physiological traits. And furthermore, what if I don't want the government to have a biometric profile on me? Then what do I do? There's a lot of iffy issues. Lastly, in the medical and humanitarian sectors, biometrics have plenty of uses. They're used to look up patient records, help diagnose patients, provide authentication to access sensitive records, and provides a method for identifying refugees. The pros are pretty obvious. It helps medical and humanitarian workers work much quicker, and it makes their life easier, and helps to identify people in disaster situations where it's difficult to typically identify someone. However, we must ensure that biometrics aren't used in a way that discriminates against people, and we must ensure that biometric systems are resilient in these disaster situations. And that covers our presentation. I hope that you enjoyed the crash course in biometrics, and I hope that you found the uses and ethical issues intriguing, or at least as intriguing as I found them. There's a lot of power behind biometrics, and we barely even scratched the surface of the topic, but please be aware of the data that you put out. Anyways, enjoy your day, and I hope that you learned something new. Bye-bye.